This lecture is on force and pressure. Definition of force. Force is a push or pull on an object that can cause it to move, stop, or change direction. Forces can cause an object with mass to change velocity or to accelerate, to change direction, or to remain in place if balanced by other forces. Examples of different types of forces. Gravitational force. It's the attraction between objects due to their mass. Another example of force is the frictional force, which is the resistance force that acts opposite to the direction of motion. Another example of force is the tension force, which is the force transmitted through a string, rope, cable, or wire when it is pulled tight by forces acting from opposite ends. Newton's laws of motion. Newton's first law of motion is also called the law of inertia. It states that an object at rest will remain at rest, and an object in motion will continue in motion with a constant velocity unless acted upon by a net external force. So this law emphasizes the concept of inertia, which is the tendency of an object to resist changes in its state of motion. An object will not change its motion unless a force is applied to it. Example is a book on a table will stay at rest until someone pushes it. Newton's second law of motion, which is also called law of acceleration. So it states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. So this law quantifies the effect of force on the motion of an object. It tells us that an object will accelerate in the direction of the net force applied to it, and the amount of acceleration depends on the object's mass. The mathematical expression of this law is F equals ma, in which F is the net force, m is the mass, and a is the acceleration. Example is, pushing a car requires more force to accelerate than pushing a bicycle. And the reason is that the car has greater mass. Newton's third law of motion, action and reaction. It states that for every action, there is an equal and opposite reaction. This law states that forces always occur in pairs. When one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. Example: action: when a rocket launches, the exhaust gases are expelled downward. Therefore, the reaction is the rocket is propelled upward. Mass versus weight. Definition of mass. Mass is a fundamental property which quantifies the amount of substance in an object. Mass remains unchanged regardless of location, and the SI unit for mass is kilograms, or kg. Definition of weight. It is force exerted by gravity on an object, and the SI unit for weight is newtons. The formula for calculating weight is W equals mg, in which W is weight, m is mass, and g is the acceleration due to gravity, which is approximately equal to 9.81 meters per second squared. Pressure. Definition of pressure is the force exerted per unit area on the surface of an object. And the formula for pressure is P equals F over A, in which P is the pressure, F is the force applied perpendicular to the surface, and A is the area over which the force is distributed. Units of pressure. The SI unit of pressure is Pascal or PA. 1 Pascal equals 1 Newton per square meter. Other units of pressure are the following: bar, atmosphere, and pounds per square inch or PSI. Examples of pressure. Atmospheric pressure. It is the pressure exerted by the weight of the atmosphere on the Earth's surface. At sea level, atmospheric pressure is approximately 101,325 pascals, which is also called 1 atmosphere. Another example are the hydraulic systems. Pressure is used to transmit force through a fluid in systems like car brakes and hydraulic lifts. And another example is solid mechanics, in which the pressure exerted on a surface by an object resting on it, such as a table supporting a book. Let's work on some examples. Question is, a soccer player kicks a ball with a mass of 0.5 kilograms, causing it to accelerate at 10 meters per second squared. What is the force applied to the ball? So here we have to use the formula F equals ma. So the force equals the mass of the object, which is 0.5 kilograms, times the acceleration, which is 10 meters per second squared. So we get 5 newtons. Next question is, a person pushes a 15 kilogram shopping cart, causing it to accelerate at 2 meters per second squared. What is the force applied to the cart? Answer, we have to use the formula F equals ma. So the force equals the mass of the cart, which is 15 kilograms, times the acceleration, which is 2 meters per second squared. So the final answer is 30 newtons. Next question is, if you lift a 10 kilogram box with an acceleration of 3 meters per second squared, how much force are you applying? The answer is F equals ma, mass of the object is 10 kilograms, and the acceleration is 3 meters per second squared, so the force applied is 30 newtons. Next question. A knife exerts a force of 50 newtons over a blade area of 0.0005 meters squared. What is the pressure applied by the knife? So we have to use the formula P equals F over A. Therefore, pressure equals force over area, in which force is 50 newtons and the area is 0.0005 meters squared. So the final answer in pascals equals 100,000 pascals. Next question. A hydraulic press applies a force of 1,500 newtons over an area of 0.1 meters squared. What is the pressure produced by the press? Again, we have to use the formula P equals F divided by A. Therefore, pressure equals 1,500 newtons over 0.1 meters squared. So the pressure equals 15,000 pascals. Next question. A truck tire exerts a force of 20,000 newtons on a road surface area of 1.2 meters squared. What is the pressure on the road? The answer is pressure equals force over area. Therefore, pressure equals 20,000 newtons which is the force, divided by the area, which is 1.2 meters squared, and it equals 16,666.67 pascals.